we are asked to solve this problem. So we can see z to the fifth is equal to negative 7,776i. We are given some restrictions. We're asked to make sure that theta, or the argument, lands in between 270 degrees and 360 degrees. And then if we need to do any rounding, let's make sure that we round to the thousandths place. All right, so we want to convert it into kind of a similar form that we can deal with, so that if we have sort of matching on both sides, then we can see how they link together and we can solve from that way. So first thing I'm going to do is I'm going to go ahead and convert it into polar form so I can see how they link together. The first one, z to the fifth, I'm going to use Euler's method. Euler's method is that z is equal to the magnitude, or r, e to the I theta. So when I look at this, if it's z to the fifth and z is equal to this, it's like I can replace z with the Euler's method equivalent. So I now have r to the e I theta, that's what z was, to the fifth power. Okay, I'm going to go ahead and let's focus on this first. So I'll do this as like side work so I can figure out what it is. And when you have something to the fifth power, let's see. This would be r to the fifth, whatever that r is. We have e. An exponent to an exponent means multiply. So this exponent's applying to everything inside here. Every factor gets that fifth power. So the r gets the fifth power, and this e to the I theta gets that fifth power. But a power to a power means multiply. So this turns into, let's put I out in front, 5 theta. I 5 theta turns into that one. Now I can kind of see what, and then I'll re-represent this in its polar form so I can see what it looks like, extended out. So we have r to the fifth, and e kind of goes away. It turns into those trig functions. Cosine, the theta is this part right here, so that's 5 theta, plus I sine, same theta, 5 theta here. Okay, and so far this looks pretty good. Then I will do the same thing, kind of try to change this number into its polar form. Okay, so that I'll call that side work 1. Got that. And then side work 2, I'll play with that negative 7,776. So negative 7,776i. Well, to change it into its polar form, it's helpful to know what it looks like on the coordinate axis. So here's the real part, here's the imaginary part, and negative 7,776i is down here. 7,776 on the imaginary axis. So that's where that's at. So if I want to know what that argument is, so this going all the way around, it hits this axis, that's the 270 degrees is its argument. And this distance right here, I'll use a different color. This distance right here is its magnitude, and that distance is always positive. We're talking about distance, not where it lands. So that distance right there, r is equal to, I'll call that r2. Let me make that adjustment. I'll call this r1 that we're dealing with. This r2 is 7,776 units long. And then we have the argument of 270 degrees. So if I write this out in its polar form, the same form as this one right here, it turns into R, so I'll just, I kind of neglected what it was. This is R cosine of theta plus I sine of theta is the general form for the polar form of complex. So I'm rewriting this in using this form right here. Our R is 7,776, parenthesis, cosine of the theta, the argument is 270 degrees. 270 degrees. Now, as I'm writing this, I remember that we can go around again and hit that 270. We can go around again and hit that 270. So we can keep doing that as many times as necessary. So it's real important that when we do this, we consider the fact that we can go around over and over again to hit there. So we would say plus, we use some constant k. It's an integer, so k is an element of the integers. Integers meaning plus or minus regular numbers. So it could be any integer times 360 degrees. So what that means is we land on 270, and then if we have 2 right there, then it would go around again. 3 right there would go around again. So it can keep going around and around as many times as we want, or that needs to happen. So that's the cosine plus I sine of that same argument right here, which is 270 degrees plus k 360. And remember, that's the sine part right there. Okay. Now, let's see. It looks like and then I'll close the parenthesis. All right. Now, we're equal. So I found out what z to the fifth was. Z to the fifth was this guy. And the negative 7,776i was this long guy here, where k is part of the integers. I'll put all of that together and set them equal, and then we should be able to make some advancements about solving. All right. So this was all our side work, just kind of working it out. I'll see how much of it fits right here. So we have r1 to the fifth power cosine of 5 theta plus I sine of 5 theta. All of that is equal to this monster. So 7,776 cosine of 270 degrees plus k 360 degrees plus I sine, and then it's this guy, 270 degrees, the argument, plus k 360 degrees in final parenthesis. Now, things match up on both sides. If everything is the same on both sides, all the forms are the same, then the parts that are different also match. So that means this R1 and this R2 match, because everything else is the same here. So R to the fifth is equal to, R to the fifth is equal to 7,776. Should have brought my calculator. And we have the arguments here. So this is one part. The other part is 5 theta. This part matches with what? 5 theta matches with the 270 plus k360, 270 plus k360. So this is equal to the 270 degrees plus k 360 degrees. Let me get that calculator. All right. And we have, so when I type this on the calculator, we don't have fifth roots. So what we do is we use the exponent 1 over 5. The exponent 1 over 5. Remember, we multiply. Exponent to an exponent means multiply. So what we do to one side, we do to the other. And those go away, and we're left with r is equal to, what is 7776 to the 1/5 power? So 7776, exponent key, 1 divided by 5 equals 6. So I found out my r is 6. Then I will calculate what the theta or the argument is. And then we kind of, the whole point of this 360 degrees in that cycle is we want to make sure that it's fitting the frame or the range that they kind of wanted us to be in. So I'm going to divide by 5 here. What you do to one side, you do to the other side. Every term gets divided by 5. Two ways you can draw a big 5 over a big fraction bar and then 5. I like to actually show what I'm doing here. So everything gets divided by 5. And we got theta over here equals 270 divided by 5, 54. K, 360 divided by 5, 72. All right. Now, I use kind of like a guess and check method for finding out where this lands in between here. So I'll say 54 plus 72 equals 126. So I got, when K is 1, I got, do it like this. When K is 1, it equals 126 degrees. When K is, I'll do sub 1. When K is 2, plus 72, 198 degrees, plus 72, 270 degrees. Is 270 degrees okay? No. We have to be greater than 270 degrees. There's no equal sign there. If there was that equal sign, yes, that would be, but there's not. K to the 4th plus 72, 342. Hey, there's 1. That lands in that range. And then if I add, I'll just do one more. K5, you never know, plus 72, 414. There might be more than 1. So we got this one right here. 342 degrees is our theta. So what all this work, this is our side work for that one. All that means is that when I plug in the number 4 here, so what would happen is I go around this 4 times and then I land into the place that I need to be. So my theta is equal to 342. All right. I'm going to circle it because things got pretty messy over here. That's important. That's important, what we did all that work for. All right. So now that I have what R is, now that I have what theta is, I'm going to go ahead and plug those into the polar form, this polar form here, and I will find out what the rectangular form is. So notice our original problem had I in it, so that means we don't want to have like cosines and sines. This is rectangular form, so we want our answer to also be in rectangular form. So if this R distributes to each one, it's R cosine of theta is the real part, plus R I sine theta is the imaginary part. Let's put the I in front. Okay, so that's what I'm calculating on my, let's plug our numbers in so you see it. Our R is 6, cosine, the theta is 342 degrees, plus I times 6, sine of 342 degrees. All right. Make sure you're in degree mode. We're talking about degrees here. So I'll do this one first. Cosine 342 equals times 6 equals. So for this one, I get 5.7063 tens, hundreds, thousandths, dot, dot, dot. That's all I need. I'm rounding there. And this one is plus I. Do the same thing. Sine of 342 is equal to, it's a negative, and then times 6. I got 1 point negative, so that's a negative, 1.8541 dot, dot, dot. We're asked to round to thousandths place. So all of this turns into I'm rounding, 5.706. That minus sign makes that minus. I'll put my I in front so it doesn't get in the way too much. 1.8. Oh, I like it better at the end for this rectangular. 1.854 I. And that looks done.